Today we will be investigating exponential functions. In the past we have worked with algebraic functions such as polynomial, rational, and radical functions. When we move into exponential and logarithmic functions, they're called transcendental functions. The definition of an exponential function is a function of the type f of x equals a to the x, where a is greater than 0 and a cannot equal 1 and x is any real number. There are some points to ponder here that I would like you to be prepared to discuss in class. They are, why does a have to be positive, and why can a not equal 1? Graphing an exponential function by hand is easy. Simply choose values for x that are close to 1, particularly -2 through 2. And remember two properties of exponents that are important. One is that anything raised to the 0 power equals 1. The second is that a negative power means to use the reciprocal. So, in this situation, y equals 3 to the x. First we'll do 3 to the -2nd. The negative means we're looking at the reciprocal, so it's going to be 1 over 3 to the 2nd, or 1/9. When we do 3 to the -1, that means the reciprocal again, so 1 over 3 to the 1st is 1/3. 0, remember anything to the 0 power is 1. 3 to the 1st power is 3. 3 to the 2nd power is 9. We graph those points, and I realize you're not going to really be able to graph 1/9 and 1/3 very easily. Just kind of approximate. Notice 0, 1 is important, and then 1, 3, and 2, 9. So what we end up with is a curve that looks like this. Now you'll notice there's actually a horizontal asymptote there at y equals 0. That's because negative exponents just mean the reciprocal. It does not mean a negative number. So we're never going to get a negative value for y unless something has been added or subtracted to the expression. Now pause the podcast and graph A through C on the same graph. Compare and contrast the graphs and write down your thoughts on the note sheet. Continue on with the examples on your note sheet and answer the questions regarding how it compares to functions that we have graphed in the past. What does the A do? What does the B do? What does the C do? What does the D do? Repeat that for all of the functions, and again, be prepared to discuss your ideas at the beginning of class. Graphing an inequality is exactly the same as graphing an inequality for any other type of function. The first thing we have to do is determine the type of boundary line, sketch the curve, test which side to shade. So in this particular example, because the problem is greater than or equal to, we know we're going to have a solid boundary line. Our function was 2 to the x plus 1. So -2, or 2 to the -2 is 1/4, plus 1 is 1 1/4. 2 to the -1 is 1/2, plus 1 is 1 1/2. 2 to the 0 is 1 plus 1 is 2. 2 to the 1st is 2 plus 1, which is 3. And 2 to the 2nd is 4 plus 1, which is 5. So we have some points. We know we're going to draw a solid boundary, so let's go ahead and graph those. -2, 1 1/4. -1, 1 1/2. 0, 2, 1, 3, and 2, 5. Now, it was a solid boundary, so we're going to sketch that in first. And notice that what the plus 1 did was moved our horizontal asymptote up to 1 instead of 0. And now we're going to test 0, 0 in our original inequality. So 0 is greater than or equal to 2 times the 0 plus 1, or 0 is greater than or equal to 3. No, that would be 2, which is false. So we are not going to shade the side of the test point because that side was false, and we're going to shade above our exponential function. That's all there is to doing that. Exponential functions are used in the real world every day in ways that affect you. Some examples of its usage are in microbiology, with growth of bacteria, spread of viruses, things like that. Medicine, when you are prescribed a drug, sometimes you have to build up a certain amount in your bloodstream and maintain it at that level, and the exponential functions help determine the dosages to make that happen. Science and archaeology, they use that for carbon-14 dating to find out when dinosaurs lived, how long ago something died. Criminology, establishing blood alcohol content in relation to the time of testing and the last drink, or establishing time of death. And in banking, with things like compounding interest on savings accounts, certificates of deposit, and costs of mortgage. We're going to look at the basic exponential equation that can be used in these situations. The equation is commonly written in one of 3 ways. Either n equals n sub 0 times the quantity of 1 plus r to the t, or n equals n sub 0 times 1 plus r over n to the nt. And the third way it's written is a equals p times 1 plus r over n to the nt. The last way is the way that they commonly use it in banking. It's the same formula, except instead of n representing the final amount, n represents the a represents the final amount, and instead of n sub 0 representing the original amount of whatever item it is, p represents the principal or amount that you put into the count. So basically what we have is n represents the final amount at the end of the compounding period of time. N sub 0 is how much you started with. R is the rate of growth or decay as a percent. If it's growth, R is positive. If it's decay, R is negative. T is the number of time periods, or usually the unit of time, and N is actually the number of times something is compounded per unit of time. So let's take some examples and show you how it works. The average rate of growth of a population in a city is 7.5% per year. The city's current population is 22,750 people. What is the expected population in 10 years? So we have to determine in the formula which numbers we know. We do not know the final amount. That's the question. What is expected in 10 years? We know the original amount of people. N sub 0 is 22,750. We know the rate of growth. R is 7.5% or 0.075. We know the unit of time is 10 years. And N, the number of times something is compounded, it's per year and 10 years. Our unit of time matches. So in that case, N is once, because it happens once per year. These are where you're looking at. Now, we simply substitute the numbers in. So N equals 22,750 times 1 plus 0.075 over 1. You can just write that as 0.075 to the 1 times 10. Now, when you're doing these, be sure that you go ahead and multiply that out either in your head or your calculator before you start so that you don't make a mistake with your calculator. So basically our problem is N equals 22,750 times 1.075 raised to the 10th power. Go ahead and use your calculator and determine that answer. My solution was that the number of people would equal 46,888.5 people. Now, anytime you're dealing with something that you can't have a part of. In other words, you don't have a part of a person. We're not talking about an arm or a leg or a body part. We always round these up. So our answer is going to be 46,889 people. Now let's go ahead and take a look at the next example. We have Sabrina. She's investing money in a money market account. She wants $9,000 at the end of 10 years, and the question is, how much is she going to have to invest if she wants to have that $9,000 at the end of 10 years at 6% interest, compounded quarterly? That's a big difference. So we're going to start with N is how much she has at the end. Well, that's our $9,000. N sub 0 is how much does she have to put in now. That's what we're solving for. R is her interest rate, which is 0.06. T is 10 years. But since it's quarterly, little n is 4 times per year. Now we substitute the numbers into our formula, and we'll have 9,000 equals n times 1 plus 0.06 over 4 raised to the 4 times 10. Or 9,000 equals n times 1 plus 0.06 over 4 raised to the 40th. If I want to solve this equation for n, I'm going to have to divide both sides by 1 plus 0.06 over 4 to the 40th. So I'm just going to simply enter that into my calculator, and I'll show you the calculator keystrokes to get the answer. So my calculator keystrokes are 9,000 divided by parentheses 1 plus 0.06 divided by 4, close parentheses, raised to the 40th power. Go ahead and punch that into your calculator, see what you get. I came up with $4,961.36. Now, that might put her about a penny shy at the end of that 10 years. I would say just go ahead and put in 4,962. For 64 cents, it's not worth the effort. This concludes today's podcast.